What if I told you there is an ocean of liquid water hidden inside Pluto? Not frozen, but liquid, sitting in total darkness under kilometers of ice, right now, as you watch this. And what if I told you that ocean may be older than every living thing that has ever existed on Earth? Older than the first fish, older than the first single cell that ever divided in our planet's seas. That should be impossible. Pluto is the coldest, most forgotten world in our solar system. We demoted it, we mocked it, and then we turned away from it for almost 20 years. A dead rock at the edge of everything. That was the story. The story was wrong, and the thing that proves it wrong is one of the strangest discoveries in the modern history of planetary science. So, before we get to the ocean, you need to understand why every scientist on Earth was certain it couldn't be there. If you're new here, subscribe, because the edge of the solar system is about to get much stranger than you were taught. Now, let me take you 5.9 billion kilometers from the sun. Out there, sunlight is almost 1,000 times weaker than it is on your skin right now. High noon on Pluto is dimmer than the last grey light after sunset here on Earth. The temperature sits around -230 degrees Celsius. That is cold enough that nitrogen, the gas that makes up most of the air you are breathing, doesn't just turn to liquid, it freezes solid. Out there, the air itself becomes rock, and the world holding all of this is tiny. About 2,300 kilometers across, smaller than our own moon. Every model we had going into 2015 said the same thing about a body that small, that far from any heat. It should have frozen completely, all the way through billions of years ago. No movement, no activity, just a frozen fossil sitting in the dark, doing absolutely nothing since the solar system was young. That was the consensus. Every textbook implied it. And then, on July 14th, 2015, a spacecraft the size of a grand piano tore past Pluto at nearly 50,000 kilometers an hour and destroyed all of it. The spacecraft was called New Horizons. It had flown for 9.5 years, across 5 billion kilometers of empty space. And it couldn't stop. It couldn't slow down. It had just a few hours to photograph a world no one had ever seen up close, and then it was gone forever into the dark. But in those few hours, it found something that broke the models on the very first detailed image. And it starts with Pluto's heart. You have probably seen it, that enormous, pale, heart-shaped region on Pluto's surface. One half of that heart is a vast plain called Sputnik Planitia, roughly 1,000 kilometers of frozen nitrogen, sitting inside what looks like an ancient impact basin. And from a distance, it looked smooth, impossibly smooth. That was the first problem, because a smooth surface on a world 4.5 billion years old means something has been actively erasing the craters. The rest of the solar system, every small, cold object is scarred with impact craters dating back eons. Sputnik Planitia had almost none. The surface looked younger than 10 million years old, and in geological terms, that is this morning. So something was repaving it, and the question was what? And when the close-up images came down, the smoothness turned out to be a lie. Because the plane wasn't flat at all, it was divided into cells, polygons, each one 10 to 40 kilometers across, separated by shallow troughs. And they looked exactly like the surface of a pot of porridge at a low boil. That comparison turned out to be almost literally correct. In 2016, 2 separate teams publishing in the journal Nature, one led by William McKinnon, one led by Alex Trowbridge, showed that those cells are convection. The nitrogen ice is slowly churning. Warmer ice rises in the center of each cell, spreads out, cools, and sinks at the edges, and one full turnover takes about 500,000 years. Sit with that for a second. On a world that was supposed to be frozen solid, the ice is circulating, like a lava lamp set to geological time. But convection needs heat from below. So where is a dead, frozen dwarf planet getting the heat to keep its surface churning? Hold on to that question, because Pluto is about to make it much, much worse. Next came the mountains. New Horizons found entire ranges, rising 3 to 5 kilometers above the surrounding terrain. And here is the part that matters. At Pluto's temperatures, water ice doesn't behave like the ice in your freezer. It behaves like granite. It doesn't bend and it doesn't flow. It fractures and it holds its shape like solid bedrock. These mountains are made of water ice, behaving like stone. And they weren't ancient, worn-down stumps. They had sharp ridges and clean faces, the signature of mountains that are geologically young. Something pushed bedrock-hard mountains up out of the surface of a world that should have had no energy left to push anything. And between those mountains, there were glaciers. Not water glaciers. Glaciers of frozen nitrogen flowing down from the highlands, pooling into Sputnik Planitia, carving channels, leaving flow marks behaving exactly like rivers of ice on Earth. Pluto is running an active resurfacing operation at a temperature that would freeze oxygen into a solid brick, and it is still happening today. Every one of these discoveries points back to the same buried question: where is the heat? And then New Horizons found the thing that turned that question into something close to frightening. It found a volcano. In Pluto's southern hemisphere sits a mountain called Right Mons. It is about 150 kilometers wide and 5 kilometers tall, with a deep crater-like hollow at its summit. The New Horizons team was very careful at first. They called it a possible cryovolcano. Volcano that erupts not molten rock, but a freezing slurry of water ice, ammonia and methane. Because calling something a volcano on a world this cold is an extraordinary claim. The evidence arrived in 2022. A study led by Kelsey Singer, published in Nature Communications, confirmed it. The terrain around Right Mons has almost no impact craters, which means it was resurfaced recently. And to build the landscape they were looking at, more than 10,000 cubic kilometers of material had to have erupted from multiple sites over multiple events. Nearby, an even larger structure called Picard Mons rises around 7 kilometers high. There is nothing else like this anywhere in the imaged solar system. Picture standing there. Total darkness, the sun is just a bright star in the sky. The ground crunches under your feet, and in front of you is a mountain that once erupted a slurry of ice and ammonia into air so cold that it froze before it could spread. A volcano made of ice on a world that shouldn't have the energy to melt a snowball. So the question is no longer whether there is heat inside Pluto. The question is what that heat is keeping warm. And the answer is underneath. Beneath the ice, the thing every clue so far has been quietly circling. Because Pluto almost certainly has a hidden ocean, and the way scientists found it is some of the most elegant detective work in modern space science. Go back to that heart one more time. Sputnik Planitia doesn't sit just anywhere on Pluto. It sits almost perfectly on the line connecting Pluto to its largest moon, Charon. In 2016, a team led by Francis Nimmo, publishing in Nature, showed this is almost certainly not a coincidence. The odds of that basin landing that close to that line by chance are only about 5%. For it to have drifted into that exact position, there has to be extra mass hidden underneath it. And the cleanest way to hide extra mass is a layer of dense liquid water beneath the ice. Then it got specific. In 2024, researchers at Washington University Alex Nguyen and Patrick McGovern modeled the cracks in the basin. They concluded the ocean likely sits beneath an ice shell 40 to 80 kilometers thick. And the water itself is around 8% denser than Earth's seawater, salty. Salty enough that you would float in it, the way you float in the Dead Sea. But that leaves the oldest question of all. How does a tiny frozen world hold onto a liquid ocean for billions of years without it freezing solid? And the answer, published in January 2025, rewrote where Pluto came from entirely. A team at the University of Arizona, led by Adine Denton, published a study in Nature Geoscience that did something no model had done before. It accounted for the real structural strength of ice and rock at these brutal temperatures. And they found that Pluto and Charon did not form the way we always assumed. They didn't form from a violent, shearing impact like the one that made our moon. Instead, a young Pluto and a young Charon collided and stuck. They briefly fused into a single, spinning object shaped like a cosmic snowman, before separating again while staying locked in orbit forever. The researchers named it Kiss and Capture. And here is why that matters for the ocean. That collision and the friction as the two worlds slowly separated would have poured enormous heat into Pluto's interior, which means Pluto could have started its life warm enough to hold an ocean, even if it formed late, even if it formed cold. If that model is right, then Pluto has kept a hidden ocean for nearly the entire history of the solar system. A reservoir of liquid water, sitting in permanent darkness, sealed under kilometers of ice, untouched by sunlight since before anything on Earth was alive. And here is the part that should stay with you. Pluto is not special. Out in the Kuiper belt, 8 of the 10 largest objects have large moons, similar to the Pluto and Charon system. If kiss and capture collisions are common out there, then hidden oceans might be common too. Thousands of dark, frozen worlds pass Neptune, each one possibly holding liquid water beneath the ice. Now think back to where we started. We spent 76 years calling Pluto a planet, then 9 years arguing about whether it deserved the title, and almost no time at all actually understanding what it was. And the entire time we were arguing, it was out there, 5.9 billion kilometers away, running a chemistry lab in the dark, churning its frozen heart, pushing up mountains of stone-hard ice, erupting volcanoes of frozen slurry, and holding an ocean older than life itself. There is a proposed mission to go back, and it's called Persephone. The journey would take 28 years, but the mission may never be funded. So for now, everything we know comes from a single spacecraft that got just a few hours on one afternoon in 2015 and changed everything. And that is the part that really stays with me. Every time we visit something small and cold and far away, something we were certain would be boring, it turns out to be extraordinary. Enceladus, Triton, and now Pluto, which means the edge of our solar system was never a frozen graveyard at all. It is full of buried oceans we simply haven't found yet. We just had to stop looking away long enough to see them. Thanks for watching.